Good afternoon. Today we will begin Unit 3 in Discrete Mathematics. The Unit 3 is divided into two parts. The part 1 is probability, while the second part is the recurrence relations. So in this unit, we will study basics of probability along with a topic known as recurrence relations. So probability, the topic is something which you have already studied in the previous classes. So over here, why do we need to study probability in discrete mathematics or even in computer science? In computer science, probability theory plays an important role in the study of complexity of algorithms. So for the complexity of algorithms, we need probability. Apart from that, ideas and techniques from probability theory are used to determine the various problems and also various deterministic algorithms. Probabilistic algorithms can be used to solve many problems that cannot be easily or practically solved by deterministic algorithm. Now, what do you mean by deterministic algorithm? Deterministic algorithms are where we can easily determine whether the solution can be obtained or not. So in this case, what we do is we use probability. In the case of probability, the programmer makes a random choice. Okay, so probability is basically take we take a choice, and based on that we try to find what is the probability that random choice is selected. So in that case, the probabilistic method is basically you make a random choice and show that that event may happen or not. Now, the random choice and the events that I'm talking about, we'll study the definition in detail in a bit. But for now, probability theory can also help us answer questions that involve uncertainty. So suppose if you're uncertain about something, what is the chance that what is the chance that when you toss a coin, tail may occur? So in that case, you are uncertain whether a tail may occur or you may get a head. Okay, so in that case, if you have studied even a little bit of probability, you will know that there is a 1 by 2 or 50% chance that the head or tail may occur in the case of tossing a coin. So also in the case of computer science, to determine whether we should reject an incoming mail message as spam based on the words that appear in the message, or even rejecting a call based on the numbers that appear. So recently in the application, in the calling applications, a few of the numbers appear as spam. How do we determine that? We determine by checking the probability of that number being a spam number. So now let's begin the topic. So in this topic, in probability, we have two topics to be studied in the syllabus, which the first one is an introduction to discrete probability theory, where we will study the basics of probability, like the basic formula and the complement of an event, union of two events, probability of union of two events, etc. While the next topic will be expected value and variance. So these are the two topics in the syllabus. Now, first and foremost, we'll study the definition of probability. What does probability mean? Probability is basically the likelihood of a given event's occurrence. So probability is likelihood of a given event's occurrence. Given event's occurrence. So basically, whether an event will occur or not, how likely something is to happen. Or we can even say it in the following way: how likely something is to happen. Okay, so example will be the example that I've already given, which is tossing a coin. So tossing a coin, whenever a coin is tossed, there are two possible outcomes. So the different results that may occur when you are taking care of when you are going through an event, that is known as outcome. So this term is very important. That is outcomes. So what are the outcomes when you toss a coin? So this tossing a coin is an event, and when you go through this event, there are different outcomes. What are the outcomes? The outcomes are, it may be head or it may be tails. Whenever you toss a coin, you have two scenarios. One is heads and the other is tails. Now if you are denoting the probability of heads with p of h, it will be either you may get a head or you may get a tail. So it will be 1 by 2 and 1 by 2 for even tails. Okay, so if it is a coin which if you toss it, you will get two outcomes. And similarly, apart from that, if you are throwing a dice or throwing a die, so dice is a plural while die is singular. So if you are throwing a die, when a single die is thrown, there are six possible outcomes. Okay, when you are throwing a die, if you if you have noticed the die, it will have six sides. So it is basically in the form of a cube. It will have six sides, and the six sides will be numbered as 1, 2, 3, 4, 5, 6. Now whenever you throw this die, what is the probability of getting any one of them? So what is the probability of getting a 1? So let's denote it by p of 1. P of 1 will be, you may get either 1 or 2 or 3 or 4 or 5 or 6. How many total outcomes you have? You have totally 6 outcomes. Out of that, what is the probability of getting a 1? It is 1 by 6. Similarly, for p of 2, it will be 1 by 6. So for each of them, each of the numbers on the die, the possible outcome, the probability for any of the possible outcome will be 1 by 6. So by using this, we can define the probability of an event happening. So probability of an event happening, the formula can be given in this terms. Total number of outcomes, total, what will be the total number of outcomes? That will be in the denominator, while number of ways it can happen. Okay, so probability of an event happening. Now what is the event? The event may be getting a tail or getting a head. And what is the number of ways it can happen? The event may happen in one way. You may even either get an head or a tail by the total number of outcomes. So let's see an example with the same. Before that, let's see a few of the definitions. An experiment is a procedure that yields one of a given set of possible outcomes. So tossing a coin is an experiment, and getting a head is the event. If you are selecting this as your probability to find out how many heads, whether a head occurs, then it is an event, while both the results, head and tails, are outcomes. So both of them are outcomes. The sample space S of the experiment is the set of possible outcomes. So this, considered as a set, is known as the sample space. An event is a subset of a sample space. So E is basically a subset of a sample space. So from the sample space is basically all the outcomes, and event is one of the outcome from the experiment. And a random variable is a function that assigns a real value to each outcome of an experiment. So for each outcome, we give some value. That is, head may occur only once, tail may occur only once. Similarly, if you have two coins, and then in that case, if you are tossing the two coins separately or together, then this outcome or this sample space will change. Now after that, what do you mean by a random variable? A random variable V is any variable whose value is unknown or whose value depends on the precise situation. So in this case, a random variable V, if we are taking an example, the number of students in a class today. So if I am uploading the class today and what are the number of comments. So in this scenario, if I'm considering the number of comments, I may not know how many comments will be given on the video until the end of the class. So in that case, this is a random variable. The value is not known, or whether it will rain on Friday or not. So this is also a random variable. This will not be known until the event occurs. So the proposition V is equal to Vi may have an uncertain truth value. So the truth value is not known. Whether the rain will happen on Friday, whether it is true or false, it is uncertain. And this, whenever it is uncertain, it will be assigned a probability. So whether it rains or not. So there are two outcomes. So there is a 50% chance of raining on a Friday or raining tonight. Now the next thing is, let's see the definitions. If S is a finite non-empty sample space of equally likely outcomes and E is an event that is a subset of S. So S is your sample space, that is all possible outcomes, while E is your event. And what is an event? It will be one of the outcomes from your all possible outcomes. Then the probability of E, whether this event happening or not, is given as P of E is equal to the number of times E may occur by the total number of outcomes. The probability of an event is between 0 and 1 only. So the probability of an event will always be between 0 and 1. It will be some decimal value, or if the probability is high, that means it will be 1. Now let's see an example. An urn contains, or a bag contains 4 blue balls and 5 red balls. What is the probability that a ball chosen at random from the urn? So over here, urn can be considered as a bag. From the urn is blue. So now total how many balls we have? We have 4 blue balls and 5 red balls. Let's solve it over here. So the number of balls are 4 blue while 5 red. So these are the number of balls in a bag. Okay, so we have these number of balls. Now whenever someone is picking from the bag, so which ball will he get? So what we need to know is, what is the probability that if you're choosing randomly from the bag, the ball is blue. So totally how many? So if the event is given as E is given as choosing a blue ball, what is the formula for choosing a blue ball? P of E will be equivalent to the total number of outcomes by, so the number of times the event is occurring by the total number of outcomes, E by S. So over here, what is the total number of balls we have? The total number of balls we have is 4 plus 5. We have to add the balls. Why are we adding the balls? Because total the number of balls in the bag from which we are choosing will be blue balls plus red balls, so it will be 9. While what is the number of blue balls? The number of blue balls is simply 4, so it will be 4 by 9. Okay, so the number of blue balls is 4 while the total number of balls is 9. So the probability of choosing a blue ball when you're choosing randomly is 4 by 9. Okay, so this is the solution. So solution for this question is 4 by 9. Now, what is the probability that when 2 dice are rolled, the sum of the numbers on the 2 dice is 7? So here you are considering 2 dice, and we need to consider the sum of the numbers on the 2 dice to be 7. Okay, so if you're throwing 2 dice, the sum of numbers on the 2 dice should be 7. So basically, how many total outcomes will you have? Let's see the total outcomes for the dice. So we will have, why am I writing a set? Because the sample space, this is your entire sample space. So you will have 1 comma 1 on both the dice, or you may have 1 on one dice and 2 on the other dice, 1, 3, and this way you will have till 1, 6. Okay. Apart the other next case will be where you will get 2 on the first dice, and similarly to 1, to 2, and this continue till to 6. And this will go on till you get all the possible scenarios, which will be 3, 1, and 4, 1, 3, 2, 4, 2, and so on. Then 5, 1, and then finally 6, 1, 6, 2, and so on. So over here, now the question was the sum on both the dice should be 7. So the sum on both the dice should be 7. This is our question. And what will be the probability that the sum of both the dice is 7? So in this case, we have to find all the possible outcomes where the sum will be equivalent to 7. So there are 6 total outcomes we had were 36. The sample space was of 36 pairs. Now, what is the 6 successful outcomes? The 6 successful outcomes are the 6 successful outcomes are 1, 6, 2, 5. So 1 plus 6 is 7. 2 plus 5, similarly 7. 3, 4 will result in 7, 4, 3, then 5, 2, and 6, 1. Okay. These 6 scenarios will give you the sum 7. So the sum is 7 in these 6 cases. So what will be the probability? The probability will be the total number of outcomes. So let me write it over here. The probability will be the total number of outcomes is the denominator. So over here, I have 36. And what are the successful outcomes? There are 6 successful outcomes. So 6 by 36, which will be equivalent to 1 by 6. Okay. So this is the ordered pairs. These are the ordered pairs which will result in the sum being 7. Hence the probability that a 7 comes up when 2 fair dice are rolled is 6 by 36 or 1 by 6. Now let's see the next question. What is the probability that the numbers 11, 4, 17, 39, and 23 are drawn in that order from a bin containing 50 balls labeled with the numbers 1 to 50? So basically you have a bin where you have in which you have 50 balls, and on each of the ball we have a number like 1, 2, 3, and we have 50 numbered on that ball. Now for that scenario, we are supposed to get 5 different. So over here we have 11, 4, 17, 39, and 23. So if we are picking up balls from that bin, 11, 4, 17, 39, and 23, what is the probability that you will get these 5 balls? Now you have 2 conditions. What are the conditions? So the first condition is if the ball selected is not returned to the bin before the next ball is selected. So in this case, suppose if we are picking up a ball, the ball is not returned to the bin. In that case, first we have to find out the number of possibilities. So the number of possibilities will be, if you are picking a first ball, you will have 50 choices. For the second ball, you will have 49 choices. So this is something we have already studied in permutations and combinations. So 48 choices, 47, and 46 choices. And this is the reason we are using product rule is each of the task is done differently. Now totally these are the number of ways we can select the ball. Now the probability that 11, 4, 17, 39, and 23 are drawn in that order only, in this order only, if we are picking up the balls, it will be 1 by this number, 50 into 49 into 48 into 47 into 46. That is, this is the total number of outcomes. Total number of outcomes. While this is only one way in which we are picking up the ball. Now what is the next condition? Let's see the next condition. The condition is the ball selected is returned to the bin before the next ball is selected. So in this case, if I'm trying to find the next ball to be selected, it's that if I'm returning the ball which I have already selected. So each time you will have 50 choices. So it will be 50 power 5. The total number of outcomes is 50 power 5. Why is it 50 power 5? Because once I am selecting a ball, so from the bag, first ball is selected, and then to select the next ball, I am putting back the first ball. So each time you will have 50 choices. 50 into 50 into 50, you will have 5 times. Okay, for the first ball, this is the choice for the first ball, second, third, fourth, and fifth. So 50 power 5. Now what will be the probability of selecting the ball in such a way that you will have 11, 4, 17, 39, and 23? The probability will be 1 by 50 power 5, because this is only one event where you will have the balls in this order. So 1 by 50 power 5. So the earlier problem was without replacement. We were not replacing the ball each time. So this condition, the A condition, is without replacement, while this condition is with replacement. We'll continue the next in the next class.